looking for an antiderivative of the function 1 over x. If you try to use the power rule here, 1 over x is, we can rewrite as x to the negative 1. If you try to use the power rule for integrals, then I'm going to add 1 to the power and get x to the 0 and divide by the new power. X to the 0 over 0. I'm not even going to write it down because that's horrifying. We can't divide by 0. That doesn't make sense. Doesn't make sense as an antiderivative. Doesn't make sense just as a function. So definitely not that. Hopefully you're screaming at me right now, but I know what the antiderivative of that is because we do. 1 over x is the derivative of the function of the natural log function. So, well, what is it, just that? Well, let's think about this for a minute. There's actually a domain problem here. The domain of the function that I'm trying to integrate, whose antiderivative I'm trying to find, 1 over x, x isn't allowed to be 0, but x can be anything else that I want it to be. So the domain is anything but 0. The domain of the natural log function, you may remember, is positive values only. Well, that doesn't seem kosher, right? I'm going to get the antiderivative and say, oh, by the way, original function, you can't use your whole domain. Instead, I would like an antiderivative that works everywhere on the domain of the function that I was trying to integrate. So I need to fix it so that I'm never trying to take the derivative, since I'm never trying to find the natural log of something where x is negative, because we can't. It's not part of the domain. So, well, we're thinking about some way of ensuring that this value is positive all the time. There might be kind of something leaping to mind. How about this? Absolute values are positive all the time. And that's true. Well, that seems like it would solve the problem, but we have to make sure that this is really true, that the derivative of the natural log function is, natural log of the absolute value of x is really equal to 1 over x everywhere, and that we're not messing something else up by just throwing an absolute value in there. So let's see. Maybe you remember from your past that the absolute value function I could really write as a piecewise function. If x was already positive, the absolute value of x is the same as x itself. So if x is 5, the absolute value of x is 5. The absolute value doesn't change anything. If x is negative, then the absolute value of a negative number is its opposite. If x was negative to begin with, if I take its opposite, then it's positive. Hopefully this makes sense if you remember the graph of the absolute value function also. The graph of y equals x to the right, slope of positive 1. The graph of y equals negative x to the left, slope is negative 1. So that means the absolute value, or the natural log of the absolute value of x, I could write like this. That means the natural log of just x, when x is positive, actually x is not 0 in any case. And for values of x that are negative, it's the natural log of the opposite of x. And now I'm going to take a derivative. of each of these. Let's see. If x is positive, the derivative of natural log of the absolute value of x is 1 over x. No problem. That's what we needed it to be. We needed it to turn out to this, 1 over x. The derivative of the natural log of negative x, well, let's see. The derivative of the natural log function is 1 over its argument, so 1 over negative x, times the derivative of what's in here. The derivative of negative x is negative 1. Negative 1 over x times negative 1 is 1 over x, which is how we needed it to turn out. So the derivative of the natural log of the absolute value of x, that's a mouthful, is 1 over x regardless of whether x is positive or negative. So that will work as the antiderivative of 1 over x. The antiderivative of 1 over x, or x to the negative 1, is the natural log of the absolute value of x plus the constant of integration.